Welcome to the 1987 Nobel Prize in Physics. This one went to another couple of IBM guys. So the 86 prize and the 87 prize both went to, in part, at least to people from the IBM research labs, which is kind of an interesting thing. It's not just, big universities. This went to Georg, Bednorz, and Alexander Miller. Mueller, sorry, apologize. Now George is the guy on the thumbnail for this, and he does kind of look like he's about to star in like a 70s cop show, but he was actually a scientist working at IBM Labs. They won the prize for their work in ceramic materials, in particular superconducting ceramic materials. Now, if that sounds familiar, we've talked about superconductors before, and what those are is essentially conductors like a wire that has no resistance. So, sometimes when you plug something in, it gets hot, resistive heating, you lose electricity in that transfer as it comes through your walls. As you plug something in, you lose it in the extension cord. You don't get perfect transmission from the power plant to your light bulb. That's not how it works. You do lose some in the transmission. Superconductors change that. They have no resistance whatsoever. They just say, okay, I'm taking electricity in at one end, I'm spitting it out at the other. Bingo, bango, there you go. No resistance. But there's a catch. When they were first discovered in 1911, they only worked at liquid helium temperatures, which is negative 269 degrees centigrade, otherwise known as freaking cold. There was a Nobel Prize awarded for that for 1913. Now, shortly after, in the 70s, an alloy got to negative 250 degrees centigrade, so a little bit warmer by like 19 degrees, but still freaking cold. And actually, two prizes came out of that: the 72 and 73 Nobel Prize, both theory and experiment, in part were wrapped around that jump in superconductivity. Now we fast forward to 1987, and these guys was switched over to a ceramic material, and they managed to add another 12 degrees, but we're still at negative 238 degrees centigrade. But the Nobel Committee said, hey, that's worthy of a Nobel Prize. That tells you how important these things are. And by the way, there's another Nobel Prize for superconducting stuff in 2003. So what's the downside? Well, the downside is exactly that. They work at really low temperatures. So you have to keep them cool just to the point of no return, which costs you more electricity than you save by using the superconductor. So the goal has always been get one at room temperature or better. Get one that works in Texas in the summertime heat. And why might you want to do that? Well, because if you do that, you can actually unplug 15% of the power plants we use to produce electricity. So we could actually say, okay, look, we have to produce 15% more than we use because electrical line loss, because of all that resistive loss. You use superconductors and bingo bango, you can just turn off 15% of it and you save a bunch of power production. There is a couple of catches to that even. Typically, superconductors work better in DC than they do in AC. You do get a little bit of a loss in AC. Not nearly as much as the resistive loss, but it is still there. So it's not perfect. But what this could do to change lives is cause us to have to produce far less electricity. Now, that may not sound like a lot for your house. That may not sound a lot for my house, your office, school, wherever. It was one school is 15%. Who cares? How many schools are there? How many houses are there? Think of the whole globe. How much much electricity would we be producing if we could save 15% of it just right off the bat by just flipping out which conductor we use? That would be awesome. That would be a huge number, especially as populations continue to grow. That could really be massive. So people do continue to work in this field and try to find that sort of silver bullet, room temperature or better superconductor. Not there yet, but it is important. Thus, 5 Nobel Prizes falling out of this stuff should tell you just how important it is. Anyway, hope you've enjoyed this one. We'll see you on the 1988 prize. Don't forget to click like and subscribe, and we'll see you soon.